Namaskar children. In this module, we are going to look at a few past paper questions in statistics. The focus of this module is primarily on median. The concepts of mode, median and mean have been explained in the earlier videos. And here we look at certain specific questions basically on the median part. So here comes the first question. The table shows information about the time taken by 400 people to complete a race. So here we have the time taken in minutes and the frequency for the corresponding time taken. As the first part of the question, you basically need to estimate the mean time taken. I'm just going to quickly go over the steps for doing the mean calculation. What we need in this case is the mid value which will come as the middle value of these time intervals which are given to us. So between 45 to 50, the time interval, the mid value becomes 47.5. Between 50 to 60, the mid value then becomes 55. Similarly, we're going to find the mid value for each of these intervals. So now we are done with the mid values. We can complete this table in terms of this extra row which we've added. So basically this is the column of frequency f, and now we're going to treat this as x, the variable which is changing in terms of the mid value. So the next column that we need is the fx column, wherein we multiply the frequency with the mid value. I'm going to write the answers for f multiplied by x in the last column here. So let's complete this column also. Once the table is complete in terms of the mid value and the corresponding values of fx, in order to find out the mean, what we need is the summation of fx divided by the summation of f. So in which case we add up all these values to get the summation of fx, which comes out to be equal to and the total frequencies, as the question says, is 400 people. So the sum total of all the frequencies will be 400. So in order to get the mean, what we do is 2982.5 divided by 400, which comes out to be equal to 72.70625, which essentially does fall in the range of the final answer which is given in the question. Next part of the question is about completing the frequency table. So when the time given is less than equal to 50 minutes, we'll basically complete the cumulative frequency column for the table. So the people who complete the race within less than 50 minutes is given to be 23, which we get from our earlier table. It's already there in part B. The number of people who complete the race in less than equal to 60 minutes will obviously include the earlier 23, and we need to add on this extra 64. So that's how we get 87. And similarly, the cumulative frequency table keeps growing. So for m less than equal to 70, it's going to be all the previous values added, and along with that we add the 122, which is only the frequency for the interval of 60 to 70. And we continue with the same procedure. So that's how we get a 345 here by adding an additional of 136. And similarly, we get 371 by adding an additional 26. And the last value 400, which will always match with the total number of people who participated in the race, by adding an additional of 29, which is there in the last column. So thereby we complete the cumulative frequency table. On this grid, we are supposed to draw a cumulative frequency diagram. As you can see, the diagram is already drawn over here. So we should draw this curve as a smooth curve. And then we use this particular curve in order to estimate values of median and as the required parts of the question may be. All right, so as we need to do over here, we need to use the diagram in order to estimate the median. Now we know that the median is the exact center part of the distribution. Since the distribution over here is 400, the total number of values is 400, exact half of that would be 200. So on the y-axis, we locate the 200 and draw this line perpendicular to the curve and find the point which corresponds to the curve on the x-axis, which in this case comes out to be equal to 70. Hence, the median for this distribution is 70, which falls within the range of the answer which is given in the marking scheme. Next part, we need to find out the interquartile range. We know in order to find out the interquartile range, we need to find out the lower quartile, that's Q1, and also the upper quartile, which is Q3. The lower quartile is basically 3/4 of the entire distribution. So when we say 3/4 of the entire distribution, it is going to be around the point 300. So this is where Q3 is going to be located at this point. And similarly, when we say lower quartile, Q1, that is going to be 1/4 of the entire distribution. So this is where Q1 is likely to be located. So we do the similar thing, drop a line perpendicular and on the curve, and by way of this we get 83 as the upper quartile and we get 61 as the lower quartile, and the interquartile range essentially is the difference between the two. So that gives us the value 22, which again falls within the range of 20 to 23. For the last part, the 60th percentile, the 60th percentile is nothing but 60% of the complete frequency. Since the total frequency over here is 400, 60% of 400 is 240. So we do something similar. Again on the y-axis, we locate the point where 240 is there on the y-axis, and from that point we draw a line to meet the curve, and here again we draw a perpendicular to get the corresponding value on the x-axis, which is a 74. So the 60th percentile for this distribution is 74. Moving on to the next question here now. 200 students estimate the volume V meter cube of a classroom. The cumulative frequency diagram shows their results. So in this question, the cumulative frequency diagram is already drawn. I want you to notice that it's not necessary that the cumulative frequency curve will always start from a 0. Like in this case, it starts from 100. It may sometimes not, on the x-axis, it may not essentially start with 0. It may start with a mid value, or depending on the values which are given in the question, and accordingly the curve is plotted. But in this question, the curve is already given to us. We need to infer information on the basis of the curve. So there go the questions. We need to find out the median. Since we are talking about the total number of students being 200, so n is equal to 200. So the median is going to be the value at the halfway through of the complete frequency, which is 100. So which means this point is where the median is going to lie. So as in the previous question, we draw a straight line, trace it all the way to the curve, and finally locate the point where it meets the x-axis, which in this case is 400. So that brings us to the answer 400 for the median of this distribution. Now for the lower quartile, which is Q1, we know it is supposed to be 1/4 of the complete distribution. 1/4 of this distribution will come out to be equal to a 50. So which means again on the y-axis we need to locate where 50 is. There's a slight error here. The point which is marked as 30 is actually 50. So treat this as 50, and we draw the same straight line and trace the corresponding point to be 350. So that brings us to the value of the lower quartile as being 350. Now for the interquartile range, again, we need to find out Q3, which is 3/4 of the Q3, or the upper quartile, is basically the value of x, which is 3/4 of the entire distribution. So 3/4 of 200, which is equal to 150. So which means on the y-axis, we again need to locate 150. This is the point where 150 lies. So the same thing, we trace it all the way here, and that brings us to 420. So 420 is the upper quartile. But of course, we are looking for the interquartile range, which is Q3 minus Q1, which gives us the answer 70. And for the last part of the question, the number of students who estimate that the volume V is greater than 300 meter cube. Now the volume is plotted on the x-axis. So we're first going to locate the volume as equal to 300 meter cube, which is this point. Now, in order to find out the number of students who estimate the volume to be greater than 300 meter cube, if I can find out the number of students who estimate the volume to be less than 300 meter cube, I can obviously subtract that number from the total number of students and get the required number of students who estimate the volume to be greater than 300 meter cube. So looking at this curve, again we do something similar. The x point of 300, we draw a straight line to meet the curve, and this is where the curve actually meets the y-axis, and this value is a 30 over here. So which means I can say 30 students estimate the volume to be less than 300 meter cube. So well, if 30 students estimate the volume to be less than 300 meter cube, then obviously 200 minus 30, because 200 is the total number of students, are the number of students who estimate the volume to be greater than 300 meter cube. So that gives us the answer 170. Let's look at question number 3 now. 200 people run a 10-kilometer race. The table shows some information about the times in t minutes taken to run the 10 kilometers. So the first column is the time taken and the next row is the frequency. Howard takes 40 minutes to run the 10-kilometer race. Calculate his average speed in kilometers per hour. So we know speed is distance traveled by time taken. The distance of the race is given to be 10 kilometers. Divided by time taken is 40 minutes. We need to find out the speed in kilometers per hour. So 10 over 40 divided by 60 to convert the minutes to hours. And that actually makes it 10 multiplied by, this cancels here, cancels there, so gives us a 2 over 3, so which becomes a 3 over 2, which gives us the answer as 15 kilometers per hour. The next part of the question, calculate an estimate of the mean time. I'm again going to quickly complete this table to first find out the mid values, and then you need to find out the corresponding values of fx and then use the formula in order to get the answer. So I shall give you the answers and you can pause this video and tally your answers. So now for the final calculation of the mean, we again use the same formula, summation fx over summation f. All these values of the fx column, when added up, will give us an answer, and the total number of people who participated in this race were 200. So that brings us to the answer, which exactly tallies with the answer in the marking scheme. Next part of the question, oh sorry, there's an overlap here, but anyway, it is similar to the previous question, completing the cumulative frequency table. So 8 plus 22 to get the 30, 30 plus 95 to get the 125, and 125 plus 55 to get the 180. Proceeding further, we were to draw the cumulative frequency diagram, which as you can see is already there on this figure, and we're going to use this curve to infer the information that we need. We need to find out the median. So here again, median is going to be halfway through. So since the total number of values is 200, 100, so we draw a straight line, trace this, and over here on the x-axis, as we can see, one division is equal to approximately 1 unit. So this value could actually lie anywhere between a 48 to a 49, and that is an acceptable range for the answer. Now for the 90th percentile, 90% of the total frequency. Total frequency is 200. So 90% of 200 is 180. So on the y-axis, we need to locate 180. We don't need to do much because 180 is straight away there on the y-axis. We again draw a line, meet the curve, and find the corresponding point, which comes out to be equal to 55. So there you are. That's the answer, 55. For the last part, the number of people who took more than 58 minutes to run the 10 kilometers. Here again, we shall first find out the number of people who took less than 58. So on the x-axis, we need to locate 58. On the x-axis, this is where the point 58 will lie. So we trace it all the way up to the curve, and this gives us 188. It's important to note over here that on the y-axis, this is what the scale is. 5 divisions. These are 5 divisions which equal 20 units. Hence, one division is equal to 4 units. So over here, when we reach this point, this is going to be 180 above, so 184, and that's going to be 188. So 188 people took less than 58 minutes. So in order to find out the number of people who took more than 58 minutes, it's 200 minus 188, which is 12. So 12 essentially does fall within the range of the answer of 8 to 14. Here comes the last part of the lesson. In this, we are not really making a cumulative frequency curve. Rather, in a grouped frequency distribution, we're going to be using just the values of the cumulative frequency in order to estimate the estimate the median. We cannot exactly find out the median, but we're going to make a rough estimation. But this is not a graphical estimation. We're going to use the table itself to get the class interval of the median or to find out the approximate value of the median. So in this question, we have again 200 students who cycle 1 kilometer, the time intervals and the frequencies of the students. We need to find out the class interval that contains the median. So here again, we will actually have to complete this table in terms of the column of cumulative frequency of the table. So for the cumulative frequency, the first entry obviously is going to be 24. The next one, 24 plus 68, which is a 92, followed by 92 plus 72, which is a 164, and 164 plus 36, which is a 200. Now in this case, the number of entries that we have is even. When the number of entries is even, as you've seen in the earlier lesson on median, the median is actually going to be a value which is lying anywhere between the n upon 2th and the n upon 2 plus 1th value. So which means in this case, it is going to be lying between the 100 and the 101st value. So in order to find out the median, what we do is we run down the values of the cumulative frequency and we try and find the value which is closer and higher than these values. So 164 is the value which is closest and higher than the values of 100 and 101. So which means the interval which forms the median class is 3 to 4. Now, in order to estimate the median, the mean, I'm going to leave that part to you. I'll give you that the final answer comes out to be equal to 3.31 minutes. So you can complete that for yourself and tally and see whether it works. A similar question again. A normal die is numbered 1 to 6 is rolled 50 times. The results are shown in the frequency table. So there go the scores from 1 to 6 and these are the frequencies. First part, we need to find out the model score. Now, this is obviously the simplest part of the question. All we need to do is find out the maximum frequency, which in this case is 15. So we know that the model score is 1. Find the median score. For the median score, we have to take into account how many total entries do we have. since n is 50, which again is even. So we know that the median is going to lie between n upon 2 and n upon 2 plus 1th value. So which in this case is 25th and 26th value. It would be the average between the 25th and the 26th value. So which means here again, we will have to complete this table by finding the cumulative frequency. So let's go ahead and do that. Okay, so once our cumulative frequency table is ready, we are looking for the values 25 and 26 in this row. So 25 lies here, but the median is supposed to be a mean between 25 and 26. So which means over here, the median will actually be the mean between these two values. And we know that the mean of 2 and 3 is 2.5. So the answer in this case is that the median score is 2.5. To find the mean score again, you will have to add more rows to the table and basically get the fx column, complete the fx column, and again use the same formula, summation fx over summation f. I'm going to give you certain mid values so that you can cross check and see whether it tallies. And the final answer is 2.96. So that's all for the session. Thank you very much. And here comes the summary. The mean of a series of numbers is obtained by adding the numbers and dividing the result by the number of answers. So this is indeed the formula which we've been using all through to find out the mean. The median is exactly the middle value, and you just need to be careful over here because it is differently done when it is when the value of n is even. When the value of n is even, then we need to take the median as the average or the mean between two values, whereas when n is odd, we do have a single specific middle value. The mode, of course, is the easiest of all, and this is the same cumulative frequency curve which you've been using in all these questions to find out the median, which is exactly halfway through, upper quartile 3/4 the way, lower quartile 1/4 the way, interquartile range, which is a difference between these values. Thank you very much.